Hi everyone. My name is Alice. I'm from House of ZK. I'm joined here with Maxime, who is a compiler engineer at Noir, and very excited to be chatting with you today, Maxime.
Yes, thank you for having me.
Of course. Wondering if very curious to hear about how you got your start into Web3 and then also ZK. Can you tell us a little bit more about how you got started?
Yeah, I became kind of obsessed with blockchain, I'd say like during my undergrad, and I was trying to explore what kind of path I wanted to go down. And once I stumbled upon ZK, this one I was like, I don't understand it at all. I want to understand it. And then after that, I just became, I could say ZK obsessed, and I was like, I need to actually understand the underworkings of all this. And that's how I then ended up doing a master's at following up undergrad, focused on CKP, like generation, on GPUs. So then I was all committed then to ZK at that point. And yeah, so that's what I've been doing since. And then I joined Noir afterwards.
Oh, great, great.
Yeah.
So you had more of like a academic kind of focus at first, and then
Yeah,
pushing to the industry. Yeah.
it was at the time when I was like, I want to work in crypto and blockchain, but I was like not sure. And then the ZK was the one where I was like, I don't get it, so I need to get it.
Nice. And then you mentioned for your master's you were focused on CKPs within GPUs. I'm wondering about how you see the hardware acceleration space coming in. Do you see ZK being applied on GPUs? I know FPGAs are also something that people are speaking of when it comes to acceleration on the hardware. So I'm just wondering about your
Yeah,
general thoughts there.
yeah. I mean, GPUs are very powerful for obviously like parallelization, but I do think eventually we will see a move towards specific chips. And but I think that takes time. And right now, I think GPUs do provide like a very good, accessible commodity tool. While like specialized chips, it's going to be for more industrial use cases, or once actually ZK has proliferated to like someone's actually needs to generate client side proofs in a very optimized way. Maybe we'll see like a ZK chip on a phone. But that feels very far away. Maybe not though. Tech accelerates exponentially, but I think for the time being, it'll probably be GPUs, FPGAs, and obviously there's some great companies that are focused on actually the specific hardware. So I think we'll see that in the future. It's
Yeah, definitely.
yeah.
Yeah, exciting. And then I also wanted to ask you a bit about some of the challenges that you see within the ZK space. So we have seen like pretty good improvements in terms of like lowering proving costs, is a like lowering proving times as well. But there are still some barriers that are preventing more mainstream adoption for developers. So wondering if you can shed some light into some of the challenges that you see still existing within the space right now.
Yeah. So we've obviously seen like massive improvements in just generalized proving cost. And actually it's like I actually do think just scaling of like how do we get these proofs faster, especially like on a server, are somewhat of a solved problem. Like, yes, we have things we can keep accelerating, we can keep optimizing, we can keep innovating, but largely we kind of know the path to get there, I think. I mean, I think I saw recently you can prove an Ethereum block in like 12 seconds or something. It was very fast. And I think the greater challenge is constrained environments, constrained execution, client side execution, because even if you add the ZK property to these ZK VMs that exist, they still are way too like resource hungry to be computed on, let alone the browser on your like laptop, let's say your mobile phone, and you need a gig of RAM. That's very constrained environment, and I think how do we still keep it like very fast? We can have meaningful use cases and actually generate it on a client side. I think that's still like a challenging problem. And Aztec's been trying to, we've been working at it for a long time, but there's still improvements to be made like
Moving
now.
better. And do you see, just like in terms of your general predictions, do you see ZK dominating in the privacy landscape, kind of long term in the future, or do you see the maybe the combination of multiple types of cryptographic primitives, like for example, MPC and FHE have been relatively hot topics recently.
I think we will see the combination of technologies for sure. I do think ZK is like kind of an like underpins all of it though, because I think FHE and becomes like more interesting when it's like verifiable FHE. And MPC, there's co-snarks are a hot topic right now. They open up the private design space, and I think we'll be able to see, the greater adoption of kind of privacy with these technologies. They're complementary in my view. It's not like, I don't think one is gonna necessarily dominate the other. I think we'll see ZK MPC or ZK FHE in different forms. And there's some great work that's being done, especially in the recent, I'm most aware of the ZK MPC space, and I think we'll see soon with Noir, some more full co-snarks, yeah.
Yeah, absolutely. And since you work on the NOIR team, I'm wondering if you can speak about some of the value propositions behind developing your own ZKDSL compared to, say, circuit building languages where developers have to write that circuit directly, or if you're moving up the abstraction layers with ZKVMs, which I know you mentioned were a bit more like resource hungry. Yeah, wondering if you can maybe speak about some of the advantages that come with like what I personally see as this middle ground in terms of
Hmm.
that abstraction layer stack stays with ZK
Yeah.
DSLs.
So largely like the pre-existing kind of circuit building languages that existed before, well, CIRCOM is the most popular, and they absolutely serve like a very valuable use case. And I think CIRCOM is a great way to like learn about ZK as like if you're truly interested in getting into the weeds a little bit. But it's a lot more similar to like coding like a normal electrical chip. And I think it's like a very different paradigm for normal programmers. So we still have circuit building. Like Noir is a circuit, like it builds circuits, it builds these ASIR circuits that then get compiled to a backend, but it's ultimately, we want it to be more high level because we do want to be accessible and idiomatic in a way that developers are familiar with. But we did have these, resource constraints. We can't just, it would be nice to just have like everyone code in like Solidity or Rust, but then you're in this situation where now, yeah, you can't actually compute a proof on a phone without some other trade-offs that you're going to have. Maybe delegating to a server or something, but we didn't want to compromise on privacy. So we needed something that we could be more customizable for us and for our needs, but we still needed to be high level. So we thought we could find this middle ground, which I think we've now found, of we can be high level. We have these reasonable kind of defaults that people have, but once you want to get into the weeds and you want to optimize and you want to actually make like a production application, you can do that. So that maybe requires more context as an engineer, and maybe then you get into you know, you do have to know some ZK and understand things a bit more, but it doesn't stop you from prototyping an app, building an initial product, and you can get into the weeds later when you need to.
Got it. Yeah, it's really great to hear how you guys kind of your approach for navigating on that trade-off plan and trying to find that like optimized sweet spot.
Yeah.
Yeah.
We kind of Noir is very like Rust inspired, obviously by its syntax, but Rust kind of has a philosophy of like reasonable defaults, but customizable. And it's the same thing with Noir. We're trying to make it so it's like easy. You could pick it up, start writing a program. It looks like any other program, and you don't necessarily need to be very involved in ZK to understand it. But then once you're like, okay, I want to optimize for this specific use case, I can use this backend. Oh, I could like optimize in this way because I'm coding a circuit and I'm not coding a normal program. You can do all that. So that's kind of the goal. Start high level, but you can go deep.
Specialize. Yeah, and on that topic, I'm wondering if we can talk a bit more about some of the like areas within the developer experience that you guys really try to like hone in and focus on. Maybe some of the pain points that developers may be experiencing when they're building ZK applications right now. I know that you mentioned that Nora is like Rust inspired, so even though developers need to learn a new language,
Mhm.
it doesn't feel completely foreign. And then I know that you guys also have that kind of plug and play adoption with Snark-based proving systems, so providing developers with that kind of flexibility. But wondering if you can speak about some of the other like design choices that you made specifically to assist with that kind of developer experience, and then maybe also some of the
Mhm.
pain points that you're trying to address as well.
Yeah. So To that, I think there's kind of two sides to it. It's like, all right, the language itself, and then the tooling that surrounds the language. And a lot of like to highlight the things that are actually like beneficial. I think on the language side, in traditional circuit building, there's a lot of concepts that, yeah, they're just not idiomatic. So like the concept of an if statement, that doesn't like, it's not the same in a traditional, if you're just coding a circuit. So Noir tries to do, we have our own kind of IR before we actually compile to our circuit, where we run a lot of different optimizations and transformations that ultimately bring kind of normal looking code into what would be circuit code. So an if statement is going to be like flattened. And in CIRCOM or traditional language, you would have this concept of a multiplexer, which to a normal programmer is like it's not something they're familiar with. So these trying to be feature rich in our just normal language was very important, but this can hide some things. Like it can hide performance pitfalls. It can, now that you're high level and you are working on what looks like a normal programming language, you can, if you're not familiar with ZK, you're like, wait, why is my program like so big? So it does hide some things because of its high level nature. And we try to mitigate that through tooling. So I just earlier spoke about at NOIRCON about the Noir profiler that we released that is basically generates a flame graph tool that lets you kind of truly visualize your bottlenecks and see where they might be. So expanding the tooling to kind of mitigate maybe some of these things is necessary. And when you write a language, it isn't just the language. It is like tooling, community outreach. There's all this other stuff that comes with it. And so even though we try to be as developer friendly as you want, there is other things that kind of need to come into play. And we try to mitigate that through tooling, and making that tooling, though, once again, easily accessible, easy to understand. And you should be able to, get started with Noir as soon as possible. Like should take 10 minutes. It shouldn't be long.
Yeah, nice. And I really like how you mentioned that with building Noir, the aspect is not just building the language itself, but then also having to try to make developers' lives as easy as possible. So you're providing tooling, you're providing other kinds of tools, and then also on the outreach side as well, getting people to use Noir. So there's a lot of
Yeah.
different aspects.
Yeah, it's not as simple as, yeah, just making the language itself. So I mean, there is definitely lots of pros to not writing your entire DSL, but there is a certain benefit to, having that customizability, though, especially once you start to build a system as complex as Aztec. Um, a specific example to give you is Aztec. They have Aztec contracts that are written in Noir, but there's a lot of kind of Aztec specific boilerplate that existed. So we needed metaprogramming. And so we had to basically add metaprogramming to Noir that allowed you to inject Noir code with Noir code. And we had this kind of customizability to follow our specific use case that we needed, that probably would have been a lot more challenging if we were working with a different language.
Hmm.
Yes.
And just scoping out a bit, I'm wondering if you can tell us about some of the use cases that you find most exciting within the ZK space. Could be both privacy related and also beyond privacy, or
Yeah.
types of use cases that are like currently using Noir that you see as really promising.
Yeah. But the thing that excites me most is the bringing Web 2 to Web 3, and the ability to have more concrete identities on chain. That's what's most exciting to me, and specifically to mention like ZK Passport, being able to actually have like a passport level credential on chain, I think is like very powerful. And now that combined with potentially other types of credentials, and I don't have to necessarily expose to everyone on chain that, oh, I just signed in with my US passport to somewhere, and then someone can see like what I'm doing. But I can still have that on-chain credential in a private manner. I think those things are like the most exciting. And other kinds of use cases where we're bringing, Web 2 to Web 3, um, that's what excites me most. And on the more like technical side of things, I'm interested in co-snarks, like the combination of ZK and MPC, I think is going to be open up that private design space a bit more. Now I can actually have private shared state on a network like Aztec. I don't need, because otherwise it is very challenging. like with just ZK. So having that NPC, now maybe we'll be able to see, you know, just, I think the design space will open up a lot. And we saw some grant applications for Noir. One of the example ones was basically training an ML model on medical data, but you don't want to expose that medical data to everybody. So multiple hospitals could collaborate on basically training in a private manner using private shared state with ZK and MPC. The Noir, we have like a whole, in our discussions on our repo, you can see the different kind of ideas and research grants that have come out. And I think that is going to open up the space a lot.
Absolutely. And it's really exciting that we're finally at that point where we can think about applications, beyond Web3, bringing Web2, as you said, Web2 to Web3. And then also, like, now we can see different combinations, like what you said with ZK and MPC opportunities there. So I find that really exciting. But just on that topic, do you have any other kinds of predictions for how the space will evolve in the next couple of years, or in terms of like the Aztec and Noir team, what you guys have next in terms of like developments, what our audience can expect coming up?
Yeah, I think right now we are all kind of like heads down towards stability for Noir, because Noir, we pre-released our 1.0. But really with developers, and especially those who are like building more complex tools like MPC, for they just desire some form of stability. So I think in Noir you're going to see probably a similar kind of state that we're in, and then post our like stable release, you might start to see kind of an expansion of what Noir can do. With right now, we still have some challenges with how we're backend agnostic, but there's some, you can't necessarily use every backend with us. So trying to expand the amount of places that Noir is available. And on the Aztec side, also heads down towards, reaching our testnet goals. But in the broader space, I foresee I think we're probably gonna see like a convergence on like a couple ZK VMs. We see a lot of them right now. This is obviously more of my like a little bit biased take. I do think we'll see kind of a convergence to one or two winners of who's the fastest. And at that point, we can use their VM.
Yeah, absolutely. Well, thank you so much,
Yeah.
Maxim, for joining us today. Really enjoyed hearing about how you guys kind of optimize for that trade-off plane, and then also more about the developer experience but behind Noir as well, and then your general views about the space. So really happy to have chatted with you.
Yeah, it was a pleasure. Thank you.
Thank you so much. Our coverage at NOIRCON. Really incredible to see all of the tremendous strides that the Aztec team is making, as well as all the other teams from the interviews we had today. Really, we're in such a great time to be able to see this transition from theory and research to building real applications, especially within privacy preserving applications. But until then, we'll see you next time.